Hello students, we are discussing about the use of free energy in chemical equilibrium. Today our lecture number is 11 and module is 2. Yeah, so this is the lecture and this is the module. Okay, so our subject name is chemistry and the subject code is CH101 or 201. Credit point is 3 and the contact hour is 35. Okay, now these are the some of the course objective that we have. The concept developed in this course will aid in quantification of several concepts in chemistry that have been introduced at the 10+2 levels in school. Technology is being increasingly based on the electronic, atomic, and molecular level modifications. Yeah, so these are the some of the course outcome that we have for our course. That is, you are able to describe the fundamental properties of atoms or molecules, atomic structure, and the periodicity of the elements in the periodic table. You are able to apply fundamental concepts of the thermodynamics in different engineering applications. You are able to apply the knowledge of water quality parameters, the corrosion control and polymer to different industries. You are able to determine the structure of organic molecules using different spectroscopic techniques. And also you are capable, after this finishing this course, you are capable to evaluate the theoretical and practical aspects relating to the transfer of chemical products from lab to the industrial scale regarding the environmental issues. So these are the some of the course outcome that we have for chemistry subject. Okay, now this is the lecture plan for our this topic, for this chapter. Today we will discuss some of the questions and answers, and also some of the problems we will do. Okay. Yeah, so last day what we have discussed the second law of thermodynamics we have discussed, and also free energy and entropy. Okay, free energy, that is gives free energy, denoted by the delta G, and we have seen that for any spontaneous process, any reaction that is spontaneous, how we can know this? If the delta G value is less than 0, that is negative. If the delta G is negative, that is a spontaneous process. Okay, and what do you mean by entropy? Entropy, generally what will happen, the random behavior of the molecules. Okay, the random arrangements of the molecules, that is called by the entropy. Higher the randomness, higher the order of the randomness, that is that time we have the higher value of the entropy. Like if we convert one solid to liquid, what will happen? In solid, all the the intermolecular attraction force is very high, right? So that's why the structure of the solid is compact. Now while it will we will convert it into the liquid form, what will happen? The intermolecular attraction force will be less, and thus the distance between the molecules will be higher. Okay, and if the liquid will be gaseous, in gaseous state, or converted into gaseous state, that time what will happen? The all the molecules are moving randomly. Okay, the intermolecular attraction force is very weak. That's why the all the particles will move randomly. So for the gaseous molecule, the entropy will be higher. That is why from solid to liquid, liquid to gas, this conversion follows the increase of the entropy. Like if in your class, if there will be no ma'am, no teachers, so what you do generally? Generally, the student will gossip with each other. Student will roam around the class. The student will change their benches, chair, their tables. Okay. Now, while at once the teacher will enter into the class, all the students will sit in a proper arrangement. All are are arranged in a proper manner, like solid, like the case of the solid. So that is why for the in the previous case the entropy is higher, but for the next case, while the teacher will enter the class, that time the arrangement of the class will be proper. There will be no randomness, and thus the entropy will be very less. So these are the some of the explanation of the free energy and entropy. Okay, so these are the topics that we have discussed previously. Now today we will discuss some of the questions. Okay, excuse me. Now, what is entropy? What is its physical significance? As I told you, entropy may be defined as a thermodynamic function of a system whose change can be measured by heat change divided by the absolute temperature T. Okay, during each in fact it's really very small during each very small change of the process carried out reversibly, it is denoted by the symbol S. Generally entropy is indicated by the symbol that is S. Okay, represented by the S. By ds, that is equals to dq reversible by t. Q is the heat, that is dq reversible, divided by t is the temperature. Okay, so this is the definition of entropy. Now, what is its physical significance? The physical significance of the entropy is a measure of molecular disorder or randomness, as I told you earlier, of the system. The more is the randomness, the larger is the value of the entropy. Okay, higher the randomness, higher the behavior of the molecule in randomness, so higher will be the value of the entropy. For example, when a gas is heated, Q reversible is positive, right? So ds is also positive, and gas molecules will be more chaotically distributed. While the temperature we are heating the gas, that means the volume will be large. So that is why what will happen, the more molecules can move randomly, they will get more space to move the randomly. That is why the more chaotically distributed while we heating any gases. So as a result the randomness increases. So if energy is added to the system as heat, the entropy of the system always increasing. Like I told you that if we convert the solid into liquid by giving some of the energy, obviously we have to give some energy. So for that, what will happen, the entropy will increase. Again, that if we heat that liquid into gaseous to convert into the gaseous phase, so again the entropy will increase due to the increase in randomness. Okay, so this disorderliness is a portion of energy converted to useful of this work. This type of energy is called unavailable, also a measure of unavailable energy of the system. So this is all the physical significance of the entropy. Okay, our next question is explain what do you understand by the internal energy of a system. Generally, internal energy, each and every molecules, each and everything will acquire some of the internal energy, right? Like any type of molecules to which have vibration, the rotation. So by this vibrational energy, by this rotational energy, by this kinetic energy and potential energy, all these energies accumulating and are called by the internal energy. So generally for a molecule, internal energy we get for the potential energy plus the kinetic energy. Okay, so kinetic energy, there are different type of kinetics energy we have. So all this kinetic energy plus potential energy will be accumulated, and that time we will get the internal energy. In thermodynamics, the internal energy or intrinsic energy of a system is the energy contained within system. Internal energy of the system may be defined as the sum of all possible types of energy, like kinetic energy, as I told you. Our kinetic energy, how can we get? Like vibrational energy, translational energy, and the rotational energy. There are three types of kinetic energy we have for a molecule. Okay, vibrational energy, that is vibrational energy means while we have the two molecules are bonded with each other, right? Two atoms are bonded with each other, that bond is constantly vibrating. So from that, whatever vibration, whatever energy we are getting, that is called vibrational energy. Now rotational energy, if this is the two atom, if they are rotating around this axis, this rotational energy is called by the by this rotation, the sum of the energy they are acquiring, so that is called rotational energy. And translation energy, while the molecule will move. Okay, so this is called translational energy. And also they have some of the potential energy due to the interaction with the neighboring molecules. So all these are called by the all this, if we sum up all these energies, that will give us the internal energy. Okay. Yeah, due to the interaction with neighboring constituents, nuclear energy, chemical energy, etc. Okay, it is denoted by the letter U or E. The internal energy we can denote it by U either or E. In a system of constant composition, the magnitude of internal energy depends upon the depends upon the thermodynamic variables, that is pressure, volume and temperature of the system. So internal energy is an extensive property. Since these three thermodynamic variables are always interrelated by some equation, thus we can write down U equals to function of pressure temperature, function of volume temperature, or function of temperature volume. Internal energy is thus a state of function, and change in internal energy act as in a process is independent of the path followed. So it depends only on the state of the system. Okay, so this is the internal energy, and this is the significance of the internal energy of a molecule. Okay, now we will see some of the numericals that you can have from this chapter. That is, our first numerical is explain briefly the term Joule-Thomson effect. Okay, 70 grams of first of all you have to explain the Joule-Thomson effect, and after that you will some of the data are given by which you can solve this problem. Okay, so 70 gram of nitrogen was initially at 50 atmospheric pressure and 25 degrees centigrade. That means the 70 gram. Okay, so from this data you can get the number of moles of the nitrogen atom by how we know the number of moles, that is equals to weight by W by what? Molecular weight W by M. So by this data we can from this data we can know the number of moles of nitrogen. Initially P1 equals to 50 atmospheric pressure and T1 equals to 25 degree centigrade. This 25 degree centigrade we have to convert it into Kelvin. Okay, now it was allowed to expand isothermally against a constant external pressure of 1 atmosphere. Calculate delta E. You have to calculate the internal energy. Delta E means internal energy. Delta H, that is the enthalpy, and the Q, the heat of the reaction, and W, the work. Assuming the gas to behave ideally. Okay, this is the first question. So first of all, you have to calculate internal energy, the enthalpy, the heat of the reaction, and the work. Okay, also you have to find out the maximum work done that would be obtained if the gas expand reversibly and isothermally to 1 atmospheric pressure. Okay, so this is the question. Now from the first we will explain. First we have to explain briefly that Joule-Thomson effect. You know already, we have told you that Joule-Thomson effect, when a gas is allowed to expand through a porous plug, like we are having, this is a tube. From this tube we are having the gas and that is passing through a porous plug. Some porous material are given. Okay, porous plug made of cotton from a region of high pressure to a region of low pressure. Okay, so in this tube we have different type of temperature pressures from, and porous wall are there, porous plug wall there, which is made of cotton. Okay, now from high pressure to region of the low pressure, the gas expand. Okay, under adiabatic condition, the temperature of the gas increases or decreases. This change in temperature accompanied this expansion of the gas is called by the Joule-Thomson effect, right? So this is all about the Joule-Thomson effect. Now we will move to the problem that we have to do. What the internal energy, the enthalpy, the heat of the equation, and the work done, that we have to first. This is our first question that we have to calculate. So already I have told you that 70 gram nitrogen is given. This data is given. From this data we can know the number of moles, that is 70 divided by 21, right? And that is number of mole is 2.5 gram per mole. Okay, now initial pressure already they have given the data. This data is given, that is 50 atmospheric pressure, and T1 yes, T1 also given, yes, 298 Kelvin. Okay, and the final pressure P2, yes, P2 is also given, that is 1 atmospheric pressure. 1 atmospheric pressure. Since the gas is ideally expand isothermally, so del E is obviously the internal energy will be 0. Del E, change of internal energy, that is equals to 0, and change of enthalpy also 0, right? So again the gas is expanded against a constant external pressure of 1 atmospheric pressure. So that means W reversible, the work done will be, that is equals to P2 into V2 minus V1, that is equals to P2 V2, instead of V2 we can write down nRT by P2, right? This is the ideal gas equation, minus nRT by P1. So again this is the this V1 is substituted by the ideal gas equation. Now if we if we put the values here, and that will give you 1.46 kilocalorie, and delta Q here, delta Q equals to W, as delta E equals to 0. That's why 1.46 kilocalorie will be the work done as well as the heat of the reaction. Okay, so this is the this type of questions generally you have from this chapter. Okay, Next, next we will see the next question. Also find out the maximum work. The data is given and data is the same. Okay, the same question. This is the same question. Also find out the maximum work that would be obtained if the gas expanded reversibly to 1 atmosphere. The maximum work done for isothermal reversible process can be given by this inerty ln P1 by P2. All we know that W maximum for the W reversible process, that is equals to inerty by ln P2 by P1 by P2. So all the values are given. If we put all the values from the data, then we will get that value, that is 5.829 kilocalorie. Okay, so very simple questions, very easy to solve. Only what you have to remember, these are the some equations that you have to memorize. Based on this equation you can solve the problem. So first of all, while solving the problem, first of all you have to see what are the data are given, right? And then based on the according to that data you have to choose which equation we have to, because there are so many equations I have done, I have shown you. So based on which equation we can solve this problem, that you have to first identify. Okay, and then you can do the problem very easily and quickly. The maximum number you can get from the maximum number of this type of problem, generally 3 marks or 4 marks. Okay, so very easy to solve. If you know the equations, then you can solve the problem and you can get the full marks. So this is very scoring. This portion is of this chapter is very scoring, if you know the equation and if you know how to solve the problems. Okay, so these are the some of the problems. Okay, next we will move to the other problem. Next question is, a fuel cell uses the following reduction half reactions. Reduction of half reactions, that is oxygen plus water molecules and 4 electrons, and that will produce from this that will produce OH minus. For that the potential is 0.401 volt. Okay, now, and CO3 carbonate aqueous plus H2O, 7 molecules of H2O, we have an 8 electron. If it is reacting with each other, and it will form the methane gas, and 100 10 OH minus aqueous. In aqueous medium, we will have the 10 hydroxyl hydroxyl anion. Okay, and the potential is 0.110 volt. Now these equations are given, right? Now what we have to find out, what is the maximum cell voltage that can be generated. This is the first question. Second question, what is the overall cell reaction that occurs. Okay, so for first question, this is the answer. So in order that the cell can operate, so E0 cell must be positive, right? Very good. Okay, now we know that E0 cell equals to E0 oxidation reaction plus the reduction potential, E0 reduction. Okay, so that is equals to already given, that is equals to minus 0.110 volt plus 0.401 volt. Okay, you can see here, the two voltages are there, potentials are there. So now E0 cell, that is equals to 0.291 volt. Very easy. And what is the overall cell reaction? If you see these two equations, then from these two equations you can get very easily the overall reaction. Overall reaction, what is the overall reaction? That is the methane plus OH minus plus 2 oxygen molecule that will form the carbonate, and the 3 molecules of water. So this is the total question. Okay, and this is the total reaction. Very easy. Okay, next we will move to the next question. Now use standard half cell potential. Yes, okay, half cell potential we have to use to determine if a reaction will occur when the following are mixed under the standard conditions. Use E0 values in appendix E of the student textbook and SN plus 4. We know that teen plus 4 or SN plus 4, that is aqueous plus 2E, it will form SN plus 2 aqueous, and the potential is 0.150 volt, right? Okay. So the total whole reaction is like this. First of all, 2 Fe plus 3 plus 2 electron, it will absorb the 2 electron and it will form the 2 Fe plus 2, ferrous plus 2, okay, and potential is 0.771 volt, right? Now next reaction is that is Sn plus 2 aqueous. We have in the medium the Sn plus 2 ion, and it will form Sn plus 4 plus 2 electron, right? And the potential is 0.150 volt. Now the total whole reaction is represented by this. Okay, what will happen? Iron plus 3 plus tin plus 2, that will form iron plus 2, that means plus 3 to plus 2, that means iron is reduced. Okay, and tin here, look here, tin plus 2 to plus 4, the oxidation state is increasing, that means the tin atom, but tin will be oxidized here. The E0 equals to of the cell is that is 0.621 volt. The standard cell potential is positive, so the reaction is spontaneous. Okay, exactly. So iron plus 2 aqueous plus 2 electron, it will absorb 2 electron and it will produce a iron solid, for which the potential is minus 0.447 volt, and tin plus 2 will release some of the electron in a medium and it will form the Sn plus 4, and for which the potential is minus 0.150 volt. So this is the total whole reaction. Now what here the standard cell potential is the negative one, so the reaction is non-spontaneous. Okay, so this is the question, this is the answer of the question. Okay, next question is, a standard hydrogen electrode is connected to a silver plus half cell. Okay, now question A, in what direction do the electrons flow in the external circuit? And that is that is depending on the upon the potential, reduction potential and oxidation potentials. A salt bridge of ammonium nitrate connects the two half cell. What happens to the ions in this solution as cell operates? Third question is, does the concentration of H plus which we have in aqueous medium increases or decreases in the hydrogen electrode? In this galvanic cell, what should be the sign of the charge marked on the hydrogen electrode? And the last question is, what electrode is the cathode? Okay, so these are the some of the questions, easy question. There are so many questions you can see here, but questions are easy. Okay, you can see here, look, electrons flow from the hydrogen electrode to the silver, right? Very good. According to the potential, as the cell operates, ammonium in aqueous medium, we have ammonium ions flow into the silver plus, and the nitrate ions flow into the hydrogen half cell. Okay. Third question, the concentration of H plus obviously increases. The sign of the charge on the hydrogen electrode is negative. The silver electrode is cathode. Here you can see the, if you check the reaction, then you can see the silver electrode is here the cathode. In order that the cell can operate, E0 cell must be positive. Okay, yeah. So these are the questions that we have. Yeah. So next question. After passing a current of 2.80 for 2 hours, a mass of 3.89 gram of iron is produced by the electrolysis of a solution of iron salt. Determine the charge of the iron in the salt. Okay, so this is the question. Now, how we can solve this question? For the following galvanic cell, determine the cathode, anode, and E cell. Okay, zero cell. Now, what is the reaction? Nickel plus 2. Here you can see nickel solid to nickel plus 2 aqueous. Double here you can see the solid bridge. This is copper plus 2 to copper solid. Now anode, solid bridge, cathode. Anode is here obviously the nickel. Oxidation takes place always anode. In anode we have the oxidation reaction, that is nickel solid to it will release some of the electron and it will form the nickel plus 2. And cathode is copper solid, which is the reduction takes place at the cathode, that is the copper plus 2A. Okay, copper solid. Now calculating the E0 cell, we can have look here the reduction of Ni plus 2 and reduction of copper plus 2. Now reduction of Ni plus 2, that is equals to the potential is minus 0 to 0.26 volt, and reduction of the copper plus 2 plus is 0, that is equals to plus 0.34 volt. So E0 cell, that is equals to E0 cathode minus E0 anode, and that is equals to 0.60 volt. So by this equation, reduction of Na plus 2 plus E0, that is equals to this one. By this equations you can get the E0 of the cell. So this is another type of question that you can have from this chapter. Okay, so these are the some of the questions that is frequently coming, and that is very scoring if you know the how to solve the problems from this chapter. Yeah, so this is all about the today's chapter. So this is the recapitulation. Yes, we have solved some of the question answer, and we have discussed some of the question answer, and also we have solved some of the problems, which is some of the types of problems, that this type of problems are very common. You can have frequently in your exams. Okay, so yes. Yeah, so please students follow the classes regularly and do the assignment in time. Assignment, if please go through first doing the assignment. Before doing the assignment, first go through, you have to go through the study material and follow my classes. After that you can do the assignment properly and submit it within the time. I'm again repeating, please submit the assignment within time. Okay, so thank you students, and see you in the next class.